Hi and welcome to the segment of math exam questions on three-dimensional objects. Question 6. The volume of a cuboid is 180 cm cube. The base is a square of side length 6 cm. Calculate the height of this cuboid. The height is simply its volume divided by its area, which gets us to 5 cm. Question 14a. The diagram shows a solid cuboid made of identical cubes. Work out the number of cubes in this cuboid. By identifying the number of cube sides representing each of the length, width, and height components of the solid cuboid, we'll be able to arrive at the number of cubes by multiplying these together. Question B. The diagram shows the nets of two solids. Write down under each net the mathematical name for the solid. They are the cone and the pyramid, respectively. Question 22. A closed box in the shape of a cuboid has length 5 cm, width 4 cm, and height 2 cm. Calculate the volume of the box. The required volume is the product of its length, width, and height components, this being 40 cm cube. Next, on the 1 cm square grid, complete the net of this box. The added lines in blue is what this net should look like. Question 5. The diagram shows the surface of a garden pond made from a rectangle and two semicircles. The rectangle measures 3 meter by 1.2 meter. Calculate the area of this surface. The required area is the sum of the rectangle and two semicircles. The two semicircles can be consolidated to form a circle. Next, the pond is a prism and the water in the pond has a depth of 20 centimeters. Calculate the number of liters of water in the pond. We start by identifying the volumetric space, which is the area being multiplied by its depth. Then we will convert this volumetric space into liters. Next question. After rainfall, the number of liters of water in the pond is 1007. Calculate the increase in the depth of water in the pond. Depth of water increases in the same ratio as that of the number of liters. Question 10. The volume of each of the following solids is 1000 cm cube. Calculate the value of x for each solid. A. A cube with side length x cm. With x cubed being 1000, x is 10. Next question. A sphere with a radius of x cm. To obtain the answer, just equate the formula for the volume of a sphere with 1000. Then find x in accordance. Question 10. The volume of each of the following solids is 1000 cm cube. Calculate the value of x for each solid. With respect to C, a cone with radius x cm and a slant height x root 5 cm. Start by identifying h with the Pythagoras formula. Next, equate the formula of a cone with 1000 and solve for x in accordance. Question 10d. The volume of each of the following solids is 1000 cm cube. Calculate the value of x for each solid. And with respect to D, a prism with a right-angled triangle as its cross-section. Again here, equate the formula for a prism with 1000 and solve for x in accordance. Question 10a. The volume of a solid metal sphere is 24,430 centimeters cubed. Calculate the radius of the sphere. By applying the given parameters into the given formula, we can identify the value of r. Next, the metal sphere is placed in an empty tank. The tank is a cylinder with radius 50 cm standing on its circular base. Water is poured into the tank to a depth of 60 cm. Calculate the number of liters of water needed. Using the formula for the volume of a cylinder, you could essentially calculate the volume consumed by water when it's without a sphere. The required volume is therefore this volume minus that of a sphere. Next, do the appropriate conversion to get to the answer in liters. Question 10b. A different tank is a cuboid measuring 1.8 by 1.5 by 1.2 meters. Water flows from a pipe into this empty tank at the rate of 200 centimeters per second. Find the time it takes to fill the tank. Give your answer in hours and minutes. First, identify the volume of the cuboid, then divide this by its rate to get to the required time. Question 4a. The diagram shows a hemispherical bowl of radius 5.6 centimeters and a cylindrical tin of height 10 centimeters. Show that the volume of the bowl is 368 centimeters cube, correct to the nearest centimeters cube. You can show this by inserting the radius parameter into the formula for the volume of a hemisphere. In this case, the formula for the volume of a hemisphere is half that of the formula for the volume of a sphere. Next, the tin is completely full of soup. When all the soup is poured into the empty bowl, 80% of the volume of the bowl is filled. Calculate the radius of the tin. From its statement, we should need to equate the volume of the cylinder to 0.8 of that of the volume of the hemisphere and solve for R. Question 4b. The diagram shows a cone with radius 1.75 centimeters and height 6 centimeters. Calculate the total surface area of the cone. By first calculating its slant height using the Pythagoras formula, subsequently applying this and the known radius into the formula, we could arrive at this total area being 44 cm squared. Question 4b2. The cone contains salt to a depth of 4.5 centimeters. The top layer of the salt forms a circle that is parallel to the base of the cone. Show that the volume of the salt inside the cone is 18.9 centimeters cubed, correct to 1 decimal place. For what is required, I like to share two methods. The first being identifying the volume of the entire cone, then subtracting this by the volume of cone not covered by the salt. In the second method, we know that the height of the top section is only 1/4 of the entire. This translates to the volume being 1/4 to the order of 3 of the entire. This means the volume for the top section is 1/64 of the entire cone, and that translates to the required volume of salt being 63 out of 64 of the entire volume of the cone. Next, the salt is removed from the cone at a constant rate of 200 millimeters cubed per second. Calculate the time taken for the cone to be completely emptied. Give your answer in seconds correct to the nearest second. The required answer can be obtained by converting the required salt volume into millimeters cubed and then dividing by 200. That's all for this segment. Do get into our other videos under KT Tutorial channel if you've liked this.